Hello and welcome back to our course in college algebra. In this video, I wanted to discuss solving absolute value equations. Now, if you look back to a couple of the previous videos on this playlist, you'll see that we have already discussed graphing absolute value functions. And whenever you have a function that involves the absolute value operation, you would expect a V-shaped graph. Now that is going to inform how many solutions we should expect from these equations, because solving an absolute value equation, or solving any equation really, can be related to finding the intersection of two graphs. So solving this absolute value equation, absolute x equals 9, can be rephrased as figuring out where the graph y equals absolute x intersects the graph y equals 9. And since this graph is V-shaped, we can see that there are two places that the graphs intersect. So we should expect two solutions. Okay, now of course this first one I have right here is a very easy one. It's basically saying, okay, we took an unknown number x, we found its absolute value, we ended up with 9. So the two possibilities are x equals 9 or x equals negative 9. Okay, now the general strategy for solving these absolute value equations boils down to considering two cases. Now we sometimes have to do something before that. So I'm going to leave a little space there. So we'll typically have to do something before we can even get to the two cases, and then we'll consider each of the two cases independently. So let's look at something like this. It's a little more complicated because you're doing more than just doing absolute x. Okay, but let's think about this. When you're solving an equation, it's kind of a matter of detective work. It's like working backwards. So somebody's telling us they took an unknown number x, multiplied it by 2, subtracted 1, then took the absolute value and ended up with 5. So let's reverse that last step. They took the absolute value and ended up with 5. So what could they have had right before that? Well, they could have had 5. If you take the absolute value of 5, you get 5. Or they could have had negative 5. So at this stage, after they did 2 times x minus 1, they could have had 5, or they could have had negative 5. Okay, so those are your two cases. You take the expression that is inside the absolute value bars, and you set it equal to the positive version of this number or the negative version of this number. Notice I'm leaving this expression completely alone. Okay, I'm not touching it. Then we solve these two cases. So if 2x minus 1 does in fact equal 5, we isolate x, we add 1 to both sides, getting 2x equals 6, which boils down to x equals 3. If we're dealing with this case, we get x equals negative 2. How did I get that? Well, you start with your negative 5 there. You want to clear this away, so you add 1. Negative 5 plus 1 is negative 4. Divide that by 2, you get negative 2. Now, of course, when we have an equation and we're solving an equation, we can always check our answer by substituting our proposed solution into the original equation and checking whether or not it's a true statement. So if x does equal 3, 2 times 3 is 6, minus 1 is 5, take the absolute value, you get 5. Great, that one works. If x equals negative 2, 2 times negative 2 is negative 4. Minus 1 is negative 5. Take the absolute value of negative 5 and you do get 5. So both of these values are solutions to the equation. Okay, this is more complicated still because we have this extra bit over here outside the absolute value. So what I'm going to do first is this, and that indicates the general step that we're going to have to do. And that is, in general, the first step we have to do is isolate the absolute value expression. Then we'll consider the two cases once the absolute value expression is by itself, and then we'll solve each of the cases. All right, so here's our two cases. 3x plus 4 could be 9, or 3x plus 4 could be negative 9. Once again, notice, I took the expression inside the absolute value. That exact expression is in both cases. I've got absolute value of 3x plus 4. Each case involves 3x plus 4. I'm changing the sign of the thing on the other side. Alrighty, so two linear equations to solve. Subtract the 4, divide by 3, x equals 5/3. Subtract the 4 here, you get negative 13 over on the right-hand side, and you get x equals negative 13 over 3. You can go ahead and check these in your original equation. They will both work. All right, so if you have an equation to solve that involves absolute value, your strategy is isolate the absolute value, break it up into two cases, and solve each case. Typically, you're going to get two solutions. There are special cases where you only have one solution, and sometimes you will have no solutions. Okay, if we were to look at a quick example, what if I changed this over here and said negative 9 instead of 9? Well, there's no x value that's going to make this thing equal to negative 9, because when you take the absolute value of something, you're always going to get a positive. So if you do this step, you isolate the absolute value, and you have a negative on the other side, that's a scenario where you'll have no solution. Okay, so go through the assigned problems and practice these. They're really not that bad. You just have to get practice with setting up the two cases and solving each case.